Day 44 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're on day 44, guys. So I don't see any sign of us slowing down soon, guys. So I hope you guys are keeping up and paying attention and following along and staying disciplined as well. Remember, part of this page is to help build discipline and to keep people motivated to keep learning every day. This type of stuff, these LeetCode problems, is something you have to put effort into. You have to put a good amount of effort in to learn this stuff. This stuff is not easy, and the more problems you do, the more repetition you get in, the better you'll get at it. But I can't, I mean, unless you're just some type of super genius, I don't think you're going to really understand unless you stay consistent and do this every day for who knows how long. Who knows how long it's going to take. Some people, we're all moving at different paces. We all learn on a different pace. But at the end of the day, if we do this every day, then we all going to learn. So that's the goal. That's the point of this page, is for all of us to learn and to build the Swift community and stick together. You might need somebody ask for help, or drop if you need help, drop it in the comments and I'll get to it. You know what I'm saying? That's what it's for. So the network, build the Swift network and build the Swift community. Now, don't forget to like, comment, and subscribe. Go ahead, guys. Take your mouse right over here, right over here. Click that subscribe button for me, guys. And then after you do that, go hit the like button. Drop a bank emoji in the comments. All of my bankers. It doesn't take much. It doesn't take long to hit the like button and drop a comment so we can run this engagement up and build these subscribers and build this page up and build this Swift awareness, man. This is a Swift awareness page, and we're just here to do our part. You know what I'm saying? So let's see what question we have here today. We have question number 2095. Delete the middle node of a linked list. The difficulty level is medium, but you guys already know we're not going to let that deter us. We're going to do this, and we're going to keep the solution as easy and simple as possible, guys. And this is probably the second node question type of question we've done on this channel so far. So yeah, get excited, guys, because we're learning something new today. We're going to learn something new that we haven't learned before, and we're going to practice dealing with nodes and lists. So with that being said, let's read the question. The question says, you are given the head of a linked list. Delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is the n divided by 2 node. From the start, using O-based indexing, where x denotes the largest integer less than or equal to x. For n equals 1, 2, 3, 4, and 5, the middle nodes are 0, 1, 1, 2, and 2 respectively. So, guys, let's break that down, guys. It seems pretty self-explanatory, but let's look at the examples just in case, because as you can see, you might have an odd number or you might have an even number, and the even number, it might look tricky because you might say, is this really in the middle? But I'll explain to you why this node is in the middle when we get there. But first, let's look at example 1. Example 1 is a little bit easier to understand. So you have an input head equals an array of integers, or a list of integers, 1, 3, 4, 7, 1, 2, and 6. The output is 1, 3, 4, 1, 2, and 6. So you see what they did here? They just removed the 7 because it was in the middle. You had 3 integers on this side, 3 integers on this side, 7's in the middle, remove 7. That's simple. Let's look at the explanation just in case, see what they say. It says the above figure represents the given linked list. The indices of the nodes are written below. Since n equals 7, node 3 with value 7 is the middle node, which is marked in red after we return the new list after removing this node. So, yeah, we're just trying to remove the middle node. Hence, the name of the problem, delete the middle node of a linked list. So, let's look at example 2, because example 2 and example 3, they could be a little bit more tricky because we're dealing with an even number of elements in the list, where you might look and be like, how do you know which one is the middle, 2 or 3? Well, I'm going to explain to you how we know which one is the middle, 2 or 3. First, let's look at the input. Head equals a list, an array of numbers, integers 1, 2, 3, and 4. Output is 1, 2, and 4. The explanation, the list, the above figure represents the given linked list. For n equals 4, node 2 with value of 3 is the middle node, which is marked in red. So let's see how they got here. Remember up here it says the middle node of a linked list of size n is the n divided by 2th node. So in this example we have n equals 4. In this example n equals 4. So we divide 4 by 2. That's going to give us node 2. When you divide 4 by 2, that equals 2, right? So we look at the index 2. So it goes 0, 1, 2. That's why we delete this node right here, because this is the second node in the index, because remember it starts at 0. And so we're dividing n4 by 2, so we want to remove 2, the second index, which in this case is 3. So let's look at example 3 so that makes sense a little bit more. We have input head, array or list of integers 2 and 1. The output is 2. The explanation, the above figure represents the given linked list. For n equals 2. Node 1 with the value 1 is the middle node, which is marked in red. Node 0 with value 2 is only the node remaining after node 1, which is why the output is 2. So looking at this, you're like, how is this the middle node? It's only 2 nodes. Remember, like we said, n equals 2. You do 2 and n equals 2, and then up here it says we have to divide it by 2, right? It says n divided by 2 right here. So in this case, n equals 2. 2 divided by 2 equals 1. But we're not talking about the value 1 of the node. We are talking about the index 1 of the node. And remember, so this is index 0, this is index 1. So we're going to remove this, because we're going to remove index 1 because n equals 2 and 2 divided by 2 equals 1. So we're going to remove the first index of the list and return 2, because 2 is the only one that will be left. So I hope that makes sense to you guys. Just remember, for these type of, if it's an even number of nodes and you don't know which one is the middle, just remember it's n divided by 2. That's the index we're looking for, the n divided by 2 index or node. So let's see how we're going to solve this problem, and the solution is actually not that difficult. So that's something to be excited, guys, too, about, because it's not even that difficult. It's easy to understand, and we're all going to learn something today. So let's see what we're going to do. First, we're going to declare a constant. We're going to set that equal to dummy. Now, dummy, that's short for a dummy node, and a dummy node is going to help us when we're dealing with lists and you have to remove a list and things of that nature. So first, we're going to create a dummy node, and that is going to be, excuse me. First, we're going to create a dummy node. We're going to say let dummy equal, this one we're going to set equal to list node. Then we're going to say 0, head. Boom. Then we're going to come down here and we're going to declare a variable called slow. And we are going to cast that as a list node. And that is going to be set equal to dummy. Then, so this dummy node also helps if the list is empty as well, because the list may be empty and we will need to create a dummy node in case the list is empty. But we might not, but just in case. So then we're going to declare another variable called fast, and it's going to be set to dummy.next. So what that is going to do is if this is list node dummy or this is slow, then fast is going to be dummy.next. So this will be fast. This is slow. this is fast. I hope that makes sense for to be in this example. So then we're going to come down here and we're going to say while let next is equal to fast dot next. That's an optional, so we have to put the question mark right there. In case it's not there, we're going to say slow is equal to slow is equal to slow dot next. Then we're going to say fast is equal to next dot next. So slow is going to move down one node, and fast is going to move down two nodes. Because so it's going to be slow, it's going to move to next. Fast is going to be next. So it's going to move like that. It's going to slow is moving down increments of 1, fast is moving down increments of 2. Then we're going to come down here and we are going to say slow dot next equals slow dot next dot next. And then we're going to come down here and we're going to say return dummy dot next. So this is going to get us to the point of where the node before the one that's in the middle. And if it's in the middle, and then that's how we're going to know which node to remove. Now, let's run it and see what happens. Ooh, we have an error. What does the error say? Cannot find list node. Oh, excuse me, guys. We have a typo. Let's run it again. Oh, another typo is crazy. Cannot find dummy in scope. Oh my goodness, that dummy had 3 M's. Sorry, guys. I'm sorry. I'm moving too fast. Need to slow down. That's my fault, guys. Let's see. And that's accepted, guys. So let's submit it and see what happens. Fingers crossed, fingers crossed. Boom. 1,049 milliseconds beats 5.14% of users in Swift, guys. That is just not good at all. But at the end of the day, it works. We're going to have to get those numbers up, but we're all learning, so don't get all caught up in the numbers, guys. We're just trying to learn and learn what works and learn the way to think. We're really trying to learn how to think and understand the code that we're looking at. And I feel like this was a good example and a good starting place for beginners, which obviously I'm a beginner as well. This is only 44 days in. So I think this is a good example to learn. But sometimes if you submit it twice, it speeds up. I don't know why, but let's do an experiment. Submit it again, see if it gets better. The time got better, but that's about it, guys. But hey, we tried. Until tomorrow, guys. We'll see you then. I'll see you then. We'll be back again for another day, another LeetCode problem. Peace.